Hello, my name is Dinesh. Today we are going to talk about Eigrp in DMVPN PHASE-1. So in last video we have talked about RIP routing protocol in PHASE-1. In this video we will see how can we configure Eigrp in PHASE-1 and what is the effect when we configure Eigrp in PHASE-1. So let's get started. So here we have the topology where we have two spokes and one hub. Two edge devices I have for testing purpose. I already configured hub router with IP address of 200.001 and red router 200.002 and green router 200.003. Rest all the interfaces are pre-configured. What we need to do is we need to create a tunnel now to first establish DMVPN neighborship between hub and spoke. So let's get started and configure DMVPN in hub router first. So the command what we apply are for DMVPN here. First we need to create the tunnel, specify tunnel interface number, then assign IP address to that particular tunnel. We have 192.168.1.1. As we are going to configure PHASE-1, so hub side you just define multi-point, you don't need to specify any destination for that. We need to configure the source interface where we have public IP, we call it NBM interface. We need to configure tunnel key for particular this tunnel. We need to have authentication between spoke and hub. I am configuring NHSRP authentication. I did configure mode of this tunnel is multi-point, and we have applied the command NHSRP map. So I want to map means I need to send multicast frame. If anybody is sending multicast frame to me, this hub router says whatever frame is coming in multicast format, I am gonna make multiple copies and I am going to advertise it to all the spokes connected to this hub. Now we need to say IP MTU value. This MTU value for segment adjustment. When we want to send the traffic with the IPsec or the traffic is encapsulated in GRE, then of course we can reduce this MTU value to adjust all the headers in this 1500 bytes. So I have defined here 1440. So if I have another header like GRE header or IPsec header, that I can see all can fit in 1500. Now last I applied command is NHSRP network ID. As we discussed in last video as well about this, we may have redundant connection, like we may have two hubs, and if you want to define a topology ID for particular one hub and another hub, then we can give this network ID. Let's configure now red router, which is my spoke. So the configuration is little bit different here in spoke. So when we need to understand that configuration as well. So first command is interface tunnel, second is IP address, and the most beautiful thing about DMVPN is that when we configure spoke, the template, you create a template and you apply the same template to all the spokes. So just copy and paste the template in all the spoke, because we require the same configuration going to the hub router. So here as we can see it, I did configure tunnel source interface, which is my NBM interface Ethernet 00, where I have 200.002. I have tunnel destination this time. In hub router we did not configure this command, but in spoke we need to configure manually. We need to define okay where our destination is, and the destination will be our public IP, not the private IP. Tunnel key, of course it must be equal in all the routers. IP NHSRP authentication Cisco 123, that also must be identical. IP NHSRP map, here is the critical thing we need to understand. There are three important command. One is this, second is this, and third command is next hop server. So here what I'm going to do, this command is working in DMVPN like ARP. When we say ARP, then of course we need to find out the destination MAC address. We know the particular IP address, but in this case you need to map IP to IP. So NHSRP resolution protocol will understand if I want to send packet to 192.168.1.1, which is inside network or the tunnel IP, then of course I need to send packet first to 200.0.0.1, which is my public or NBM address I can call. IP NHSRP map multicast. If I have any multicast, I am going to just keep that multicast in GRE tunnel, and I'm gonna make that multicast packet in a unicast format and going to send it to what device. So if I have multicast, I can send that multicast to hub. So hub can now make multiple copies and can send it to all the spoke. I don't need to send the multicast directly to the spoke. IP NHSRP network ID, it must be equal IP NHSRP next hop server. So the next hop server is the most important thing. If you wanna find out, okay, where do you want to send the traffic, if even the multicast traffic or even the unicast traffic, you can send it to this private IP address once the tunnel is established. Again, IPMTU, that is also most important thing here. Let's configure another router, green router, and configuration is again simple configuration, same as it is. Only one thing you need to specify here is different, that is the IP address of the tunnel, and that IP address of course must be identical in the scenario. IP address, then tunnel source interface, Ethernet 00, tunnel destination IP, which is 200. It's a NBM address, and the tunnel key 123, and IP NSSRP authentication Cisco 123, IP NSSRP map, what this is private IP to public IP, then IP NSSRP map multicast. If I have any multicast, I'm gonna keep that multicast in GRE tunnel, and I'm going to send it to this particular neighbor. So here what I did previously and what is happening here, you cannot see the configuration because I did enable a command debug IP NHSRP. So what happened, it generated a lot of debug messages. So I can see the first debug message. What was that? Here IP NHSRP static mapping. Okay, let's go to this one message called registration request. We can see from our this perspective, registration with tunnel decapsulation module succeeded, and here we can see the packet. Let me drag this down or up. Somewhere we must see registration. Yeah, we did send registration request via 123, and where did I send it? What was the IP address? So source was 192.168.1.3, which is the IP address of green router, inside IP, not outside IP, and send it to next hop server 192.168.1.1, and I received a reply as well. So registration request and registration reply is done here, and finally what happened here, my next hop server, and we have established the tunnel, and next hop server is up now, and we built tunnel. So the command I did apply here, I can just disable this undebug IP NHSRP or undebug all. It will be better for me. So let's say now show DMVPN. Here I did make a peer is 200.0.0.1, which is NBM address. Come to hub router, and let's verify something what we can do here. So the command, if I want to apply debug NHSRP, will generate all the debugging when there is the type of tunnel interface is going to come up or going down. I can see here show IP NHSRP. Here the command will show you the neighborship. The neighborship is static or dynamic, because on hub of course the neighborship is dynamic neighborship, and in spoke you will see static neighborship. We see that we can verify now red router, and let's see show IP NHSRP and the list of peer we have with this. Here we can see it's a static, because statically we define this command tunnel destination 200.0.0.1. Now we can configure Eigrp in all the routers. So first configure Eigrp in hub router. Jump to hub router and say router Eigrp. You can configure name mode Eigrp. You can configure any other type of routing protocol, but in this we are configuring number based Eigrp. The directly connected interface tunnel IP you must give. You are not gonna advertise Eigrp packets on your NBMA network, so we need to define tunnel IP. Let's go to this router red and give this command router Eigrp 100 network 192.168.1.0. network is our loopback of red is 222, and network 192.168.25.0, which is between red and edge. Go to green router and apply the same type of command. It's a very easy to configure Eigrp. As we can see, it's a basic configuration, so we don't need to confuse here. As we can see, neighborship is coming up because we applied the proper command here. We need to configure Eigrp on both the edge devices. So I say edge 1, which is my one router connected to red router. Go to this device and say the same thing. Network 5555 loopback of 44. Sorry, this is connected between green and edge. So 4444. No auto summary. Go to now the last device, which is connected to red, and the device is edge 2. Router Eigrp 100 network 192.168.25.0 network 5.5.5.5. no auto summary, and here also we can see neighborship is up. Let's jump to hub router and verify what actually the routing table, how the routing table looks like here. Show IP route Eigrp in hub, and we can see all D routes came. That means Eigrp routes came from both the spokes, and the next hop is our tunnel IP, not the public IP. Tunnel 123. If we want to send packet to this device ping 4.4.4.4, of course we can ping. But what happens when we see the routing table of spoke device? Come to this red router and verify now. What is the difference? Show IP route Eigrp, and we can see there is a route 555 and there is a route 111 and 555. So 555 is coming from our this device. What we have is red device is connected to edge, so loopback of edge device, and one which is coming from hub. But we are not learning any route from green, any route from edge device. So what the issue now here? Devices, they are not learning any route from each other because one is split horizon rule. The split horizon is enabled in hub, so because of that we are not learning. So we have two solutions. One is to disable the split horizon, and second is to generate summary from hub. So you can generate a summary, or you can generate a default route from hub, so hub can now take care of all the traffic coming to hub. So let's take one solution and configure. So first what I'm going to do is I'm going to configure summary on hub router to have the connectivity. So this solution will generate the default route in both the spokes. So command is very simple. IP summary address Eigrp 100 and 0000 and subnet mask 00. That's it. This command is generating now default route in Eigrp. Let's go to red router and again verify what happened. And this time we can see routing table with star asterisk value, and the asterisk value says 000, that means default route. But now if you want to check the connectivity, even we are not learning, but we are learning default route, we are sending it to hub router, and hub is sending it to this. So let's say I am going to send packet to 4.4.4.4 using my loopback 2.2.2.2, and there is a full connectivity. How the packet is moving toward this 444, you can give trace route 4.4.4.4 and see the result. Of course the packet will go via hub, because hub right now in the data plane, and PHASE-1 always makes a tunnel between spoke to hub and hub to spoke. There is no direct tunnel between spoke to spoke. That can be possible only in phase 2 or phase 3. So currently we can see the packet is moving to hub and going to green router, and from green to edge router. But now this solution also can work. This solution can give you the better functionality, because you might not have a lot of routes, but it will not give the proper visibility of your network. So we can remove again this type of configuration, and we can just disable split horizon for this config. Let's remove, just give this command, again we will see the same thing. Let's remove the split horizon, very simple command. Same thing, go to tunnel 1, 2, 3 and give no IP split horizon Eigrp 100. So there is a different command, no IP split horizon. If you give that command, that means that is relevant to RIP. But if you give no IP split horizon Eigrp 100, that belongs to Eigrp. Now I can go to red router again and verify the table, show IP route Eigrp, and this time I can see all the routes appearing in my routing table. And one more important thing, we can see the next hop is being modified here. The route of, I can see the route of green device here, 4.0.0.0/32 means 4444. I am learning from my hub. So hub is now modifying the next hop and sending the update to red device. This is what happens in PHASE-1. So whenever any device is generating a route or any update to hub, hub is going to modify the next hop value and going to keep itself next hop value and going to send it to all the spoke. This is what happening here. Now one more thing about this, we may have some other type of entries in topology table of red and green device, because the split horizon rule can send packet back to the same interface where the packet came from. So if I say edge router, the route is 5555 is coming to red router. So let me draw the scenario if I can. So if I send packet from edge to red device is going to send it to hub, and hub is going to send the same packet back to red and send it to another spoke. So let's verify how can we see that message. So I can see red device is learning show IP route 555. So red device is learning this 555 from 192.168.25.2, which is my this device. But if we see the topology table, show IP Eigrp topology of 5.5.5.5/32, and we can see there are actually two routes which this red router is learning update from. So one is 192.168.25.2. second, the red router is learning the same route from 192.168.1.1, which is my hub router. So why the red router is not keeping this route in the routing table? Because of the feasibility condition here. So the feasibility condition we have in Eigrp to prevent the loop. So let's say the feasibility condition says the AD value of successor always should be less than the FD value of feasible successor. So this is my feasible successor and this is my successor. So AD value of successor must be less than the FD value of feasible successor. That's the most important thing. This is what the condition met here, and the condition met, that's why we are not keeping the route which we are learning from hub. Instead we are keeping here the route we are learning from edge device. So let's one time we can verify, and we can ping from this edge to next edge. So ping 5.5.5.5, source is 4.4.4.4, and that's how it works. So this is the phase 1 Eigrp configuration. We may have look into the phase 2 configuration of Eigrp, and this is enough. Thank you for watching my video. Bye bye, have a great day.